Hello everyone, today I am going to introduce you to COBug, a bug localization pipeline for COBOL software systems. COBOL, or Common Business Oriented Language, continues to power critical systems in various industries like finance, banking, and government despite its age. However, maintaining COBOL systems has been a challenge due to the lack of effective tools for bug localization. Traditional methods of bug localization are mostly manual and highly time consuming. That's where COBug comes in, a tool that automates the process of identifying which files in a COBOL repository are most likely to contain a specific bug using advanced machine learning and large language models. Let's take a quick look at how COBOL works. User input. First, the tool takes a COBOL repository from the user which contains your COBOL files. Bug report generation. The tool uses Gemini 2.0 Flash, a large language model, to generate detailed bug reports. These reports include bug ID, bug summary, bug description, and ground truth. The reports are saved for the reference. Bug COBOL file pairing. Each bug ID is paired with all the COBOL files in the repository, and these pairings are labeled as either 1 for the ground truth file or 0 for the other files. Feature extraction. The next step is converting the text data into a formatable, suitable for machine learning. The tool uses TF-IDF factorization to represent the bug reports, combining bug summary and bug description, and COBOL files numerically. It calculates cosine similarity and RBSM to measure the relevance between bug report and each COBOL file. Model training. With the extracted features, the tool trains a random forest classifier to predict which files are most likely to have the bug summary or bug description. Model evaluation. The tool evaluates the model using top K accuracy and mean reciprocal rank MRR to ensure its reliability. User testing. Finally, the users can input a new bug description and summary, and the tool ranks all the COBOL files in the repository based on how likely they are to contain the bug. The results are saved in a CSV file. Installation and usage. To use COBug, follow these simple steps. These are the requirements. Python requirements. Make sure you are using Python 3.9 or higher. We recommend Python 3.11 because some libraries like Google Generative AI require this version. Get your API key. You will need a Gemini 2.0 Flash API key to generate bug reports. You can get it from Google AI Studio. Just sign in, create an API key, and paste it into your configuration. From GitHub, clone the repository, navigate into COBug directory, install the requirements, run the tool. And now let me show you a running example. Here, cloning the GitHub repository, navigating to the COBug directory. These are the requirements needed. As you can see, installing the requirements, and it will ask for the, like, now running the tool. Once we run the tool, it will ask for the COBOL repository path. And here I have downloaded some repositories from COBOL dataset. I'm copying the one of the repositories path. And once we submit the COBOL repo path, then it asks for the API keys. Once they are submitted, it starts generating the bug reports for each file in the COBOL repository. Now let's check one of the bug reports generated. These reports include bug ID, a unique identifier for each detected bug, bug summary, a brief explanation of the bug, bug description, a detailed explanation of the bug and its potential causes. Once all the bug reports are generated from the given COBOL repository, before we provide input bug details for prediction, let's check the workflow of our ML model. First CSVs. It contains the bug reports along with ground and truth information, that is the actual file paths of the buggy files. Second CSVs. This is where all the bug file pairings are stored for training the model. Here, label 1 indicates the ground truth, that is the bug report belongs to this COBOL file. Bug reports are divided into 90% training data and 10% testing data. These are the results of our ML model on testing data. And these are the pre-trained model results. This is the testing data. Let's verify our model using one of the generated bug summary and description from the testing data. Here ground truth is optional. You can see the results. Here are the top 5 predicted COBOL file paths. Our model successfully ranked the correct COBOL file as the top one prediction for the given test case. COBug is a significant step forward in making the maintenance of COBOL legacy systems more efficient. Thank you for watching. Have a great day.